Exercise 18. The figure below shows the recordings of the successive positions of the tracer M of a puck on a horizontal airtable. The time constant tau is 50 milliseconds. And as you can see, the recordings are as follows. The initial position is on the origin, and the I vector is from M0 to M1, so it's 1 since the magnitude of the unit vector is 1 centimeter, M1, M2, and so on. I didn't indicate with justification the trajectory described by the motion of the puck. So trajectory is rectilinear since the successive positions of the puck are collinear. Complete the adjacent table. Concerning the table here, I won't go into the details of the values, but I'll give the general idea. So here when we say t in milliseconds, t0, it is equal to 0, starting point. Then at t1, 1 tau has passed, so 50 milliseconds. After that, we have 2 tau for M2, so you can write here 2 tau. So here I wrote tau, you can write here 2 tau, here 3 tau, 4 tau, 5 tau, but this is not enough. You have to continue and say 50 milliseconds, 100 milliseconds, 150 milliseconds, because 1 tau is equal to 50 milliseconds as given. Now if we continue for x, x is the distance from the point. Now the distance of the position of the puck of M with respect to the origin, we have M1 is 1 centimeter away from it. That's why x1 is 1. The unit is already given in the table. x2, we have to count 1 plus 1.5. You have to count the whole distance here away from the origin. It's not about M0, it's about the origin. It happened here that M0 is coincident with the origin. So it happened that it started moving from the origin of the reference. Okay, but actually we refer to the origin of the axis. So M2 with respect to the origin of the axis is 1 plus 1.5, it's 2.5. M3, 1 plus 1.5 plus 2 is 2.5 plus 4 plus 2, 4.5, and so on. We continue this way to find x2, x3, x4, x5. Now for the instantaneous speed, we cannot find v0 and v5 because we don't have information. Here we don't have information before it, and here we don't have information after it. So we can calculate only the 4 ones here, v1, v2, v3, and 4. v1 is equal to position after it minus before over t2 minus t0. So x2 is already written in the table, 2.5 minus 0 over t2 minus t0. For the instantaneous speed here, you will have that t2 is equal to 100 minus 0, yani 100 millisecond, which is equivalent to 2 tau. Similarly for the rest, even for v2, when you write x3 minus x1 over t3 minus t1, t3 minus t1 is 150 minus 50 milliseconds, which is equal to 100 milliseconds. Yani this means that it's equal to 2 tau, and this is normal because when we talk about v2 at t2, we take from m1 till m3. This includes 1 tau and another tau here, so 2 tau. Now for the acceleration a2, for example, is v3 minus v1 over t3 minus t1. Similarly, concerning the time, you either write it this way and you do like 150 minus 50 equal 100. But here I would like to mention a very important note, which is that you have the units in meter per second and meter per second square. So that's why here when you do x2 minus x0, do not keep it centimeter. You have to convert the values into meter by dividing by 100. Like you don't say for example x2 2.5, it's actually 0.025 minus 0. Okay, or you say for v2 it is equal to 0.045 minus 0.01. So you have to convert the x from centimeter to meter, and you have to convert also the time from millisecond to second by dividing by 1000. So please make sure that you fill in the values according to the given unit here, especially if it is the SI unit. Now concerning the graphs. Okay, I want to add the axes. I just use the Excel to get an accurate one, but for sure into you have to show the axes, okay, horizontally and vertically, and you have to write the parameter here, which is x in centimeter. Okay, even when you represent Okay, if it is specified concerning the units, if the units are specified, like if I ask you or you were asked that please trace the variation of x as a function of time, where x is in centimeter and t in milliseconds, so you have to stick to the instructions. Okay, otherwise you are free to use the units you like. T here is in milliseconds, and as you can see, as expected, this is a parabola starting from the origin, because the type of motion is uniformly accelerated rectilinear motion. You will see that the v is increasing and a will be constant, so v is increasing at the same rate. Okay, so this is UARM, and as we plot x by considering the obtained values here, taking convenient scale, here the most convenient scale is 1, it's accepted because the maximum one will be 10. Okay, so it's accepted here to take every 1 centimeter is 1 centimeter as a scale, so you are also responsible to determine the scale. And concerning the time, you have 0, 50, 100, 150, 200, 250. So for sure, the convenient scale is that horizontally every 1 centimeter is equal to 50 milliseconds. Okay, and you take it as such, as you can see here, 50, 100, 150, 200, 250, and you locate the points and then join them. Not, they have to look like a parabola, not a straight line, as I mentioned during the sessions. Now concerning V also, you draw the axes. Okay, you have V here, meter per second, and T again in milliseconds. And the same thing, you have to consider a convenient scale. If you check the values, we have 0.25, 0.35, 0.45, 0.55. So as if you are counting by 0.10. Okay, or you can take a scale of 0.10 is convenient. So you can take every 1 centimeter is equal to 0.10. Okay, as given here, like 0.1, 0.2, 0.3, and you will locate the points. You have 0.25 in between, you have 0.45 in between, and you locate the points by, you know how to locate the points in an orthonormal system. Now the point here that I want to mention is that according to the graph, you only have V1, V2, V3, and V4. In T1, T2, T3, T4. So you only have the points corresponding to these instants. Okay, you only have these ones. So how come we extended it, and to what limit are we supposed to extend the straight line of V versus T? Okay, you can elongate it backwards until it reaches the origin, so that you can determine the initial position, the initial speed, which is 0.15 in this case. You can go backward, but here I would like to make sure that you do not extend it beyond T5. Okay, so because maximum for this study, you are maximum given till T5, so do not go beyond T5. This is T5. Okay, so when you draw and extend the line, only extend it till T5. Do not extend it to a value or to a time further than T5, because we don't know what happened after T5. Okay, so this whole study is limited to the range between T0 and T5 that are given, so stick to them, please. Let's check if there are other questions here. This one. And concerning the acceleration of the puck, it's constant. A is equal to 2, so you can simply draw the graph. It's easy. A versus T. Okay, it's 2A in meter per second squared. Don't forget to write the units. And T in milliseconds. Okay, just as you did above, you get it 2 here. Oh, this is not straight. It should be straight. So you draw it straight horizontally. Okay, horizontally straight one. So we draw it horizontally to a value of 2, showing this is the origin and time, whatever here, the time 50, 100, and so on.